Okay then, so I'm going to try to illustrate simply how the uh, intentional mispolar alignment to deal with declination backlash will have for impacts on the guiding. So if we have our right ascension as a vector going this way, this is set by the mount motor and gearing to keep the sidereal array of 1 to track with the Earth as it rotates. So we call this right ascension. There we go. Now we do a mispolar alignment. That means that now we'll start getting a component orthogonal to the right ascension in the declination. And it can either be up or down depending on which way we do our mispolar alignment, but let's call it that way. So we call that declination. There. Now, what we can see here is that now we are going to have our right ascension vector needs to meet up with this, but it's going to have the same length as the one we have down here. So what's going to happen is that we're going to have this type of vector here. So as you can see now, what our guiding needs to do is that we need to perform action to compensate for that drift in declination, like this. But we also need to compensate for the loss in right ascension that we've introduced, like here, to get back. So this means that our guiding actually needs to work harder. Both needs to work to compensate for the declination component, and it needs to work in right ascension to compensate for the loss in tracking speed due to that component. So it needs to constantly do some extra work, and we just need to keep that in mind in case we have weighted our system on the limit, or maybe we have an unintentional mispolar alignment, which will cause this as well, and then we might have issues with guiding because our system might be struggling with these extra workloads continuously. Okay, it should be, usually that's it's not really a problem if it doesn't get too excessive, but yeah, just to keep that in mind. Yeah.